Hello, welcome to this lesson. This is an introductory lesson on a subject which I think is very important in any aviator's career: aerial navigation. Aerial navigation is very important, and the challenges and of course it's very interesting subject as well. There are dedicated papers in all your license exams on this subject. Therefore, we will find that we need to constantly revisit all our basics, constantly revisit all our subject matter uh, throughout our careers. The first lesson is about form of the Earth. The any problem in navigation starts with the study of the Earth, and in this lesson I'm just going to introduce you to the basic form of the Earth and a little bit of facts, and to kickstart the subject on an interesting note. Welcome you all. I'm sure you're going to find the entire subject very interesting. And this lesson, of course, is very basic, and to make it interesting, I added some numericals end of the lesson. Okay, let's get on to the subject. Navigation is a fundamental process by which an aircraft flies from A to B. It's a very it's a very challenging aspect to fix the position of the aircraft. Position reference systems is a very complicated subject, and over a period of years we have refined processes, refined systems to fix and reference geographic positions on the Earth. Position reference system defines a position on the Earth accurately. Understanding position referencing is a very important, Therefore, the subject on form of the Earth and is a very important to develop a basic understanding. So we are starting with the basics. Of course, the modern navigation systems are much more sophisticated, much more elaborate than what we are learning, but this forms the very fundamental of the subject. So let's move on with the lesson. Okay, let's discuss about geographic referencing systems. It should be easy to represent positions accurately on a plain paper on a two-dimensional surface for all of us human beings and of course professionals to read and understand, derive some information on any position reference on the surface of the Earth. But Earth is almost a sphere, and translating a spherical surface to a plane surface in the forms of maps and charts has its challenges. Therefore, and it's not a perfect sphere as well, as you will learn as the lesson goes. So, fixing and indicating positions on a plain piece of paper or a mathematical system is a complex subject, and therein lies the need for more and more sophisticated systems. Let's not forget the air traffic over a period of so many years has increased vastly, and we have seen that there's a need to fix aircraft positions accurately when it is flying. That means when a pilot says that the plane is at this position, it should be exactly at that position. That's the requirement. How will he fix it in middle of the air is the need of the modern navigation avionics systems, which is what we are going to learn and learn eventually on this subject. Let's see some basic definitions. Firstly, the great circle. A great circle is a circle on the surface of the earth whose circumference and radius is same as that of the earth. That means uh, its center is same as that of the earth, and it divides the earth into two equal halves. And I have shown in this picture two examples of great circles, as you can see. Between point and I may as well clarify the shortest distance between any 2 points lies on this arc of any great circle. And of course, you can only draw one great circle between any 2 points. So if you see the picture, visualize it, it will be very clear. Between A and D, I have drawn, there is a great circle which is connecting these points, 2 points A and D, and it's a full circle. Similarly, there is another great circle connecting these 2 points C and B, and between A and D, that's the arc which lies on the great circle is the shortest distance between A and D. As against this small circle, what is a small circle? Any circle which is not a great circle is a small circle. In the picture below, I have shown an example of a great circle and two small circles. It's very self-explanatory and it's very basic. So I will not spend too much time in explaining this. Let me define something called the equator, which is a very important aspect of the form of the earth. The equator can be defined as a great circle whose plane is perpendicular to the earth's axis and equidistant from two poles and divides the earth into two equal hemispheres. It is very self-explanatory, so I will not dwell too much into the definition. Look a little more in depth. The radius of the earth is about 3,441 nautical miles. So let's do some mathematical calculations. The length of the equator, that means the circumference, is 2 pi r, that is 2 into 3.14 into 3441. That works out to 21609 nautical miles. And as I have always been saying, it's not a perfect sphere. Therefore, this approximates to about 21,600 nautical miles. That means the surface circumference of the equator works out to approximately 21,600 nautical miles. This whole distance is divided into 360 equal degrees, as you will learn, and for several conveniences, which takes us to the figure of 60 nautical miles per degree. So this is a very important figure, so I want you to learn this concept very clear, because this is what we are, this forms the basic and the fundamental knowledge and the fundamental aspect of distance on the earth. Okay, let's continue. as I was telling you, the shape of the Earth is not a perfect sphere. At best, we can describe it as an ellipsoid or an oblate spheroid. It is flattened at the poles, and the diameter at the equator is 12748 kilometers, and in the polar it is 12705 kilometers. That's almost a difference of that many kilometers. If you were to take the compression ratio, it's in the order of 1:300. It's a very small compression, but nevertheless it is a compression, and since we need to measure distances very, very accurately on the Earth's surface, this compression ratio poses several challenges, and we have different navigation systems for polar regions, and you will learn all this as you progress in the subject. While on the subject, I want to cover another important and an interesting aspect of the Earth, form of the Earth. The Earth is tilted at an angle of 23.5 degrees to the normal axis, while the rotation is happening through the normal axis, but it is tilted, as you can see in the picture. This is the primary reason for all seasonal changes of the Earth and apparent movement of the Earth from north to south, and changes in sunrise and sunset timings throughout the year, and it causes lots of other effects, so which we will be learning in our due course, but I just want to mention it at this point in time. Okay, let's get on to some more interesting facts. The Earth's surface from the equator, which we already defined, which is that it divides equal halves of the Earth in the north and the south. The line, the great circle line which describes the equator, is defined as the 0-degree latitude, and thereafter it is calibrated up to 90 degrees to the north and 90 degrees to the south, equally in equal proportions. These are all called the latitudes, which are running north to south. The latitudes which lie on the northern side of the equator are annotated with the letter north, and the latitudes which lie to the south are called the southern latitudes. So let's go some more. These latitudes are measured in degrees, minutes, and seconds. And as we go up, these latitudes become small circles, and since these circles are small circles, their distance decreases as we go up. And as you would appreciate, in fact, at 90 degrees at the poles, it is just a point over the poles. So at the equator, if I were to scale as 1, and at 90 degrees it scales to 0. So if I were to explain mathematically, the distance on latitude varies as the cosine of the latitude. You would appreciate cos 0 is 1 and cos 90 is 0. So that's how the distance varies. We will be doing numericals to clarify on this particular concept. Let's see the longitudes as well. These are imaginary lines running from pole to pole. There is a primary reference longitude called the prime meridian, which is numbered 0, which you all by now should know that it passes through some place in UK. Thereafter, they are numbered in increasing value towards easterly and westerly directions, and goes all the way up to 180 degrees. So the total surface is divided into 360 degrees, as in the case of latitudes you would appreciate. So the only difference here is that it is increasing from the prime meridian towards either side, towards the east and towards the west. They are also measured in degrees, minutes and seconds. Let's get on to some actual mathematical calculations so that you will understand. So here in this picture I've shown the entire latitude and longitude graticules. You can see that latitudes I've mentioned 0 degree and 30, 45 and 60, and of course the longitudes. All along the longitudes that you would appreciate there is no variation in the distances all along the longitudes. Across it is uniformly measures 1 degree equal to 60 nautical miles. But when we go up, as we go up on the latitudes, as I was mentioning to you, that varies as the cosine of the latitude. Therefore, I've given two scenarios. One at 30 degrees north, where the cos is at decimal 866, and 1 degree will measure 60 into 0.866, that is approximately 52 nautical miles. Similarly, at 60 degree north, 1 degree change in longitude will measure its cos, that is decimal 5, that is half of the distance, that is 30 nautical miles. So let me summarize it. Along the latitude, if you have to measure the longitudes, it will uniformly measure 1 degree at 60 miles, and the latitudes would measure in a decreasing proportion as we go up between two longitudes. So some more numericals and this aspect is going to be very clear. Coming to the measurement of distances, for several political reasons, there have been different scales on which distances have been measured in different parts of the world. So we will see the conversions of these measurements. One of the three important scales are the nautical miles, the kilometer and the statute miles. So I will not dwell into the details, but I would just like to mention that 1 nautical mile equals 6080 feet, and 1 statute miles measures to 5280 feet, and a kilometer measures to 3280 feet. And I've also reflected in a table the different conversion ratios between these three scales. But in the aviation, the most popular measuring scale is the nautical mile, and of course in some parts of the world, Russia and China, they use kilometer as the basic scale. Therefore, we need to be very clear on this nautical mile to kilometer scale conversions, because when we fly in those airspaces, we have to fly as per their requirements. Okay, some numericals to clarify the concept. I have taken different scenarios so that several concepts would be clear. Question 1. This is a question on position on the equator. As you can see, it's on the equator 00 north-south. That is, what is the distance between 65 degree east and 72 degrees east? So difference in latitude is 65 to 72 is 7 degrees. So 7 into 60 is 420 nautical miles. Very simple. The next question is again on the equator. The position is on the equator, but the positions are either side of the prime meridian. That is, one is to the east of the prime meridian, the other one is to the west of the prime meridian. So which is 005 east and 008 west. So therefore, the difference in longitude would be 5 plus 8, that is 13 degrees. So the distance on the equator at the difference of 13 degrees will be 13 into 60 is 780 nautical miles. Two more numericals to clarify some more concept. Third one, this is at position 30 degrees north of the north latitude. So 30 degrees north, what is the distance between the positions 178 east and 170 west? If you notice this again, this position is crossing the international date line, and to that extent it's going to be slightly different. Therefore, the difference in latitude is 178 east and 170 west is 12 degrees. The 2 degrees on the easterly side and 10 degrees on the westerly side. So at 12 degrees, 12 into 60 into cos 30 is cos 30 is 0.86, so it works out to 623.5 nautical miles. Question 4. What is the distance between the positions 45 degrees south? This question is on 45 degrees south and 005 east and 010 west. Very simple question. It is the cos of 45 is decimal 7, so at 5 degrees difference it works out to 212 miles. I have not included any questions for distance variations along the latitude or on the longitude because they are very, very simple to calculate. I hope you found this lesson a little bit interesting. More lessons are to follow, and we will be getting more into the depth of the subject. As usual, I invite your critical comments on the email ID given. I thank you all for watching this lesson once again. Thank you.